Okay, so a little bit about functional programming. So there's basically two major paradigms in terms of how how you organize your code. There's object-oriented programming, which is what we've been focusing on, which is the dominant paradigm. And there's also another, competing slash sister paradigm called functional programming. And we're not going to get into the real high-end functional programming stuff, but there are a lot of aspects of functional programming that are generally useful, even if you're still within an object-oriented paradigm. A couple of things, and we've already seen most of them. So a couple of things in both Python and JavaScript, functions are objects, right? So you can pass them around, you can define them, and then you can pass them around, you can assign them to variables. You can do basically anything you can do with an object, you can do with a function. So that's one thing. It makes them very versatile. Some other things are like higher order functions. So can someone tell me what a higher order function is?
Is that a function in a function?
Yeah, basically. So there's two aspects. One is a function that takes a function, and the other is a function that returns a function. So you can write a function that returns another function. You can write a function that accepts a function as a parameter. So Tim, can you give me an example of a function that takes a function as a parameter? Tim, are you there? Let's see, how about Cameron?
So would an example be like the string function we learned how to modify?
The string function? Could you elaborate?
Because it's like a function within a function, and it tells you like it's a function within a function that returns how the function should be printed out when you call it.
Okay. I'm not exactly sure what you're referring to. Like the actual print function.
No, like the underscore str function.
Oh, I see. Yeah, so that's not exactly a higher order function. So that is yeah. So that's a dunder method. You can override that. But that's not exactly a function that takes a function. So the string, the built-in string itself just takes self in as a parameter.
Would it be something like map?
Yeah, exactly. So map is an example. So map, depending on how it's implemented, it basically will take an array and a function, or it is a method on array. But in either case, it takes a function, then it executes that function once for every element in the array, for example. So that's an example of a higher order function. So map is one. There's reduce. There's filter. So these are, in both JavaScript and Python have these. So these are general kind of utilities, and you can see with a higher order function, there's a higher level of abstraction. So if I write a function that, for example, doubles a number, that does a very specific thing. But if I write a function that, like map, for example, it's a higher level of abstraction. It's doing something. It's kind of like meta. It's like a meta function. It's a function that says, you can do something a certain, I'll let you iterate over this thing, and you can execute whatever function you want there. So it's a more general utility. So let's, yeah. So I'm gonna, so those are some general kind of prerequisites for functional programming. There's also a lot more advanced stuff which we're not gonna touch at all. So one question would be, why would you ever want to use something like functional programming? I mean, what is the point of having something like math? We can already iterate over a list or an array and then execute a function on it.
Faster to type. Like it might be
Yeah.
easier to.
Sure. Yeah, I mean it's less typing, less rewriting. So for example, that functionality is in one place, right? So the ability to execute a function once for every element in some structure that exists in one place. So I don't have to re-implement that every time I want to use it. So I'm not repeating code.
And what's the difference with object-oriented with
Sorry?
this? What's the difference? Because like object-oriented, like we also used it so that we don't rewrite code, so that we could reuse it. So what's the difference with it with functional programming?
Yeah, so that's a good question. So there are a few benefits to functional programming. Yeah, we're not going to go into too much depth, but there's also things like the really core idea of functional programming is that you want programs that you're very certain about. So you are very very controlled with side effects. So you don't want to have any side effects, basically. And we'll talk a little bit more as the course goes on about this kind of stuff. But the idea is I take in a value and I kind of process it through a pipeline almost. So I take some value and I can run it through any number of functions, and I can be sure that, you know, for each function I give it an input, I get an output, and then the output goes into another function. So it's basically like you think of your program as like a pipeline. I have some data and I run it through this pipeline, and at the end I get some other piece of data. So that's kind of like the core structure. And then both functional programming and object-oriented programming are concerned with, you know, not repeating yourself, keeping things organized, making things, you know, readable and understandable. So there are some core features that are common between any programming paradigm. Like, you don't want stuff to just be a mess. You want things to be organized. You want to have, you know, structure and hierarchy, and, you know, not doing weird things over here that have to be repeated over here, and changing global variables in random places and stuff like that. I'm not sure if that exactly answered your question. To give you a very detailed answer would require a little bit more than we have time for today, unfortunately.
Okay, yeah, thank you.
Okay, so I'm gonna jump into an example real quick. I'll share my screen. All right, so I'm going to start off with a JavaScript example. And so the problem, let's say, what I want to do is write a program that is going to start off with some number and then perform a bunch of different operations on that number, like double it, square it, whatever. So I'll start by just kind of writing those basic functions. So this is JavaScript now. We'll start with double.
Hey Chad, just a heads up, we have your whole monitor instead of your program, so we see like your notes and stuff like that.
Oh, sorry. Let's see here. Ah, I see. Is that, are you just seeing my VS Code window now?
Yeah, it's fixed now.
Okay, thank you. Okay. So we have, let's say, a function that can double. And we can write this in a few different ways in JavaScript. So I'm going to do it, this is a simple function, so I can do it on one line. So I'm just going to use, I'm going to make it an anonymous function. So it's going to take a single parameter, which is going to be some number. And then I'm going to double it. And I can do the same thing. You can do anything. So I'll call it square. And it's also going to take a number. It's also going to return a number. So this will be an increment, and we'll just add 1 to it or something like that. So we could have, any number of functions here. And what we want to do is I'm going to start off with some number. Starting. So you have some starting number, and then I want to do all of these. So I want to double it and then square it and then increment it by 1. So how would I do that?
Could you chain these? Could you chain these functions together?
Okay. Yeah. So that would be the ideal, and we're going to get to that eventually. But how would you chain them together?
I think I chose the wrong words. Maybe I meant to say nest them like double passing start and then have like square on the outside of that and then increment on the outside of that.
Okay. Okay. Cool. Yeah. Yeah. So I could do something like, so if I wanted to, we'll just say I'll, maybe a keyword, so but that's fine. So we'll and then whatever. So you could do this, right? So Celine, can you tell me what is going to happen here?
So then, so it will square and then double and then, oh, so it will, yeah, so it will, so the, so the increment is calling the square and then the square is calling the double.
Okay. So what's the order that these functions are actually going to be called in?
I think it's the, I think it will be the ink and then the square and the double.
Does anyone else have any thoughts?
Isn't it inside out? It would be double square increment.
Yeah, it's actually, it's not the order that you read it in English. It starts here. So why does it have to start here?
It's the innermost parentheses.
It's the innermost parentheses. So what do all these functions take?
It's also where your input parameter is at. So that's where your input parameter is. So that's where it's got to start.
Yeah, so increase, I mean, it can't really do anything with this yet. It needs a value, and it just has this basically function call. So it hasn't evaluated yet. It has to start here. Here we have a primitive value. So this function can be called and evaluate. That's going to return a number. So once that's evaluated, then square can get called. The square has a real value to work with now. And once square has a value, it can get called. This gets evaluated. And then once that is an actual value, then increment can get called, and so on. So it actually goes in from inside out. So you can see so you get 401. I assume that's correct. I don't know, but 20 times 20 plus 1. Okay, so this is definitely one way to do it. And if we wanted to, well, for one, maybe this isn't like the easiest to read. And if we wanted to switch the order, so this would be final 1, we could do final 2. We could maybe put the square here and the increment here. So this is fine and it works. But there's something that we're doing here. If we think about, higher level of abstraction, right? What we're doing is we're taking a bunch of functions and then applying them in a sequence, right? So if we're thinking about, programming, functional programming, we would like to capture that more abstract functionality and put it in one place. Kind of like we have map, where map will take a function and iterate over everything. So we could implement that kind of every time, but there's something here that we can pull out. It's it's more abstract, so it's harder to think about, but there is something there. And we actually do have a higher order function that can do that for us, at least initially. So we are starting with a bunch of functions and we're ending up with a single value. Is there any higher order function that kind of has that shape?
Is it reduce?
Yeah. So can you tell me about reduce?
I haven't used it in a long time, but I know that in JavaScript I always used it to sum the numbers in an array. So it takes in a whole bunch of numbers and then gives you one output.
Yes, exactly. So it starts with a list, something with a bunch of stuff in it, and then you end up getting one thing out of it. So there's something like that happening here, where we have a bunch of stuff and we want to end up with one thing. So because functions are first class objects, they're actual objects, we could actually give reduce a list of functions, right? We don't just have to give it a list of primitive values. We could give it a list of functions and say, okay, execute all these functions in the order that I specify in the list. So we can do something like that. So I'm going to write a new function here. I'll call it pipeline. And what it's going to do is it's going to take a list of functions. And then let's say whatever, some starting value. And then from this function, from this pipeline function, we want to return just a single value. So we're going to return something, and we're going to use reduce. And reduce, why would default to that? Reduce is going to take two things. It's going to take a function. So can someone tell me about the function that reduce takes, that reduce expects? How about Nicholas?
Which
Oh. You're expecting reduce?
Yeah. So what's the function signature of the function that reduce expects? Does that question make sense to you?
I'm not 100% sure.
Okay, so that's fine. So if I have a list like 1, 2, or an array or whatever, and I do map, map expects a function that's a single parameter and that's going to return something.
Mm-hmm.
So the signature would be, you know, give me a thing and return a thing. In this case, this would be an integer. So does reduce expect a function with the same shape here?
It should be a list and then returns one value of the list. A single value.
Yeah, so it is so the function that it's going to apply, you know, over and over again, they're actually two parameters. So it's going to expect there's going to be accumulator and then something else. And I'm just going to call this a function because in this case it's going to be a function. So I'll just write this out. So this may look a little strange, but so reduce, so map takes a function that with a single parameter and returns something. Reduce wants a function with two parameters. We've gone over this before a little bit, but so the way it works is it will execute the function and then take that value, whatever gets returned, and then pass it in as the accumulator to the next time it calls, right? So that's how you end up getting one value because it kind of saves it. Whatever the function returns, that value gets saved and passed in as another parameter here, and then at the end, this is the value that's ultimately going to get returned. So this value, if you're adding, it's just going to get, you know, whatever the first thing is plus the second thing, that value is going to get saved and passed in here, and then it's going to execute the second thing plus the third thing, and so on. So that's how this works. We can also, we don't have to just use primitive values, like I said, we can use functions because functions are objects. So we can pass in a list of functions. And then execute that function on whatever value we're accumulating. And then it will ultimately return a single value. So that may be a little baffling, but let's see if it works.
Where is list funcs, that variable?
Well, we haven't created it yet.
I see it. I see it. Okay, my bad. I didn't see it up there.
So we can do that now. So we can do the same thing that we did here. So we'll pass in double, square, and increment. And then the number we're going to pass in is the same. So starting. Okay, so I'm getting not a number and 10. 1 second.
Does the accumulator go in the end as an optional value, optional parameter?
Um,
Starting value or previous value plus the starting value, and then the accumulator, you either initialize it as something other than 0 or it defaults to 0. Or maybe I'm wrong.
so there are some optional parameters. In this case, the starting val is going to be whatever is the accumulator of the first call. So if you don't pass anything in, it will default to the first element. Does that make sense?
I guess.
So
then, what is your in your function then? What's the current value then? So I don't see like starting value. Okay, I get it. Never mind. I see what you're doing.
it's fine. So this is very
I get it.
confusing. So yeah, but the issue is there's kind of like a chicken and the egg problem where I'm start with an accumulating value, but the very first time you call it, there's nothing there because you haven't, this is basically the result of whatever you return here. But that first time you haven't called it yet, so you don't have that return value yet. So you have to start with something, and by default, it will use the first element in the list, but that doesn't really work with our case because this is the function, so we'd have to call, a function with undefined for the first time, which would not work. So we have to pass it the starting value initially, and once we kind of bootstrap the function that way, it's going to keep working because it takes in a number and a function, it returns a number, which then gets passed in here. So we have a number and a function because all these functions that we're passing in take a number and return a number. We can chain them together. So both of these get the same result, but now we have this abstraction that we can use in our code for anything. So for any pipeline that we want to create, we just basically our program is now defined by the list of functions that we pass in. As long as our functions have this shape, take in a number, return a number, we can use this.
It totally makes sense now. I was just not seeing the chain effect, but yeah, I get it now. I get it. Thank you.
So, we can make our program whatever we want, and it will just return a number because we have everything set up and like our types. So I'm not going to get into the details, but you can think of a function like this as a type. It's a specific type. It takes in an integer and returns an integer. JavaScript and Python don't really care about this. They don't have but other languages do. So in other languages, a function like this would have its own type, like an integer or a Boolean or anything else. So this is one example of functional programming where you kind of pull out some abstraction, which is maybe hard to think about, and then you make sure that your types are very precise. And once those two things are set up, again, here there's no side effects, right? I'm not printing anything in the console. I'm not, modifying global variables, anything like that. It's just inputs, outputs, taking it, returning it, taking it, returning it, taking it, returning it. And because I have that set up, it's very precise, I can trust it. And then I can just, my program can just be, here are my building blocks, and I can combine them in any way that I want. And I don't have to worry about it. Okay, so that's kind of the basic idea. So this is kind of, a small example of what a functional, a program in a functional paradigm would look like. basically like a pipeline. Start with a value, pass it through a bunch of functions, and then end up with some value. Okay. So that's kind of the basic idea of functional programming. So what I'd like to do now is talk more about kind of shifts. I'm mostly going to talk about decorators, and because that's we'll see more of that in Python. But it's basically, does anyone know what a decorator is in Python? Has anyone seen that yet? Okay, that's fine. If you haven't, then that is absolutely fine. So before I talk about decorators in Python, I just want to kind of give an example of the basic concept using JavaScript. So in functional programming, we want to do a few things. One, pull out general utilities, general like abstract utilities like reduce or map or whatever. We also might have more specific things that we want to do. For example, we might have a program where we just want to call a function once, right? So we have our core function, which could be anything. Let's just say double or whatever. But now we have this added restriction or modification where we say, okay, I want to take in a function, but I only want to call it once. I want to make sure that I'm just calling it once. So maybe, if you're like a payment processor or something like that, and someone clicks, charge my credit card, you might want to have that function only be able to get called once. So someone doesn't show up with 30 charges on their card if they're having connection issues and they keep clicking submit. So there are ways that you can implement that in a kind of functional style. So we're going to look at that. So first thing I'm going to do is we're going to look at some source code from an actual functional library. So there's something called Lodash. Lodash is a JavaScript, as it describes itself, a JavaScript utility library. Let me just scroll down here. Okay, so there's not much in the description, but so Lodash has a bunch of functional utilities in it, and it's a pretty commonly used library. Okay, so what we're going to do is look at their version of once. It's a function that makes sure that right here. Okay, so here is the source code. So this is source code. This is, professional quality source code. So can anyone take a look at this and tell me anything? How about Sean? You don't have to understand anything, but just anything about this, anything that's happening here. So what's happening on the first line?
It's importing before from the before.js.
Okay, so it's importing something. So where is this being used?
At the in the function that's returning before.
Yeah. Okay, cool. So it's importing something and then it's using it right here. Okay. Aaron, how about what's going on with this chunk right here?
I think the things in the middle are the decorators.
Okay, so it definitely looks like decorators. There's the at symbol here. In this case, they're actually not decorators, but they look like it. But can you just maybe this whole thing in general, like why is this here? Why is this whole chunk here?
Telling you what it does.
Yeah, exactly. Yeah. So it's just it's a description, right? So it's describing what this function does in normal, English. So you don't have to have this is called a doc string. You don't have to have this. You don't have to have a description, but you can. It's nice. So it tells us it creates a function as restricted to invoking func once. Repeat calls of the function return the value of the first invocation. The func is invoked with the this binding, blah, blah, blah. So we don't have to worry about that. And then here we have some more specific information. So we don't need to worry about this, but param. Can anyone guess what param is?
Like your input or your argument.
Yep. And what type is the input?
A function.
Yeah. Okay, so this is a function that takes a function, right? So what's the term for a function that takes a function?
High order.
Yeah, a higher order function. And what does it return?
Function 2.
Yeah. So it takes in a function and it returns a function. So this is kind of, like a doubly higher order function. And then here is basically a description of how you would use it. So how do you use this? What's happening here?
You have a variable that calls once, and then you keep calling it.
Okay, cool. So what is this create application?
That's the function we're taking in.
Yeah, exactly. So we don't know what this is. This is just made up for the example, but we know because of reading the doc string, and we know what this parameter has to be a function. This is func. This is func here. So whatever once takes is a function. So we're saying we're calling once and passing it in a function, and then what kind of thing is initialized now going to be?
A function.
Yeah, exactly. So we're calling the function, we're passing it in a function, and it's going to return a function. And we can then call that function. And if we call it twice, then basically nothing happens on the second time. So that's the basic idea. So here's, this is real source code that you can read, and you don't, I would suggest as an exercise, at least taking a look at source code every once in a while. Don't expect to understand it or anything like that, but it's a good habit to start getting into. Okay, so this before. So I'm gonna go ahead and we'll take a look at before. So what do we know about? What can we guess about once? What's the relationship between once and before?
I'm guessing that once will let before run once and not again afterwards.
Yeah. So we see that once is just directly calling before. And so before takes two parameters. It takes the function, which is just going to pass along, and also the number 2. So it's calling before. So once is before with 2. So, maybe we don't really know anything about how this works, but this is basically an alias. So we can guess without knowing any details about how before works that once is probably some kind of convenience, convenience for users. So it once is a special case of before. And if we look at before, so now we're looking at before, and we have the same doc string, and before is a little bit more complicated. So it takes in a parameter, and we can see that here, param number, n, the number of calls at which func is no longer invoked. So if we go back to this, so before 2 means that it's no longer invoked. So you can't invoke it twice. So you can only invoke it once. And then the function. So we don't need to worry about this. We're going to try and implement this ourselves now. So that's the basic idea. All right. Let's do. So I'm going to take a function. Let's just say double. And I'm going to write a function called once. And what is once going to accept as a parameter?
Another function.
Okay, so we'll just call it func. And how could we think about, so also, what does once return?
Another function.
Yeah, exactly. So we know that's going to return some kind of function. We don't know what it's going to be yet. So function is going to take a function and it's going to return a function. So if I'm going to implement this double once, I'm going to call once, and I'm going to pass it double. And then at some point, I should be able to call double once with some number. Any thoughts here?
So would that return 6 then?
It should, yeah. Should return 6. So what do we know about, so double once is going to be this, right? So let's not even worry about the once part. Let's just say I want to get a value here. So I want to see 6 printed out to the screen. So if I call once, I'm going to return this function. And what are some things I know about this function now? Based on the pattern here. So anytime you're asked about a function, there are two questions you should try to answer. What are those two questions?
The input and the output.
Exactly. So we know that this function is going to be equal to double once. So what does double once take as input?
An integer.
Yep. So we know that we're going to need some kind of integer here. And what does double once return?
An integer.
Yep. So we know we're going to have to return some kind of integer, and we want this to be doubled. Do we have a way to double this integer?
By calling the double function.
Yes. So inside of once, where do we have access to the double function?
By the function passed in as a
Exactly. Exactly. So we can call func with n like that. So if I run this, I get 6. This is all very like, mind gamey, but you have to like follow this chain. It's very confusing, but that's the basic idea. So we now have, this very indirect way of just doubling a function. So the basic skeleton is here now. So we have this function once, which accepts a function and it returns a function. And the return function is going to have to basically match the signature of whatever we pass in. So it's going to take in one parameter and it's going to return whatever that function returns. Now we have to make sure that it only gets called once. Any speculation? You don't have to be right. Any random thought or speculation? How might we ensure that a function only gets called once?
Could we just use like an if statement with a Boolean?
Okay, cool. So let's try that. So if something, so I guess if something is true, then I'm going to return this function.
And then make it false.
Okay. So if false, return, was it capital? I can't remember. I think it was. And let's just say we'll just return undefined if otherwise. So if we try to call this now, we've hard coded this to false. So true. Okay, so we have the basic behavior now. So we have to figure out how to make this Boolean value line up with whether or not it's been called yet.
The first line in the if statement could be, change it to false, so that the next time this goes through, it won't call that.
Okay. Okay, good. So, but what should this be? I mean,
I guess that would have to be like a variable or something.
yeah.
This might be more of a complicated answer than you were after.
No, that's fine. So we're on the right track here. We just need to figure out what this needs to be and where it needs to go. So I think one issue, if we put it inside this function here, I don't think it's going to work. Even if we put it here, like, we can do, we'll start with false. So if I try calling this, so it, let's see, that should, why is that not running? Undefined. So call this false. Okay. So let me see. Is so we could, invert the booleans, but that's fine. So is callable is true, and then false. Okay, so this works. And what happens if I call this again? Let's say if I call once.
Do we have to put the initial declaration outside of the other function? Otherwise, it's going to get reset to true, I think.
Yeah, so what's the problem here? So I've called it twice now. So you've said the answer, but let's think about why this doesn't work right now. So I create this function. Now I call once, which returns this function. Then I call this function with 3. And then I call it again with 4. But it looks like this is not changing to false. So what's the solution?
I mean, can you take that variable and put it one step outside? Just put it, I don't think that's going to work either, but maybe create a global variable somehow.
Okay, so let's try, we could create a global variable, which you should never ever do, but we can do that.
That's what I was thinking. When I said that, I was like, no, that's probably the wrong answer.
Okay, but it works, right? We can see, can you guys see the output here?
Yes.
Okay.
Could you put that variable inside, like make it a default value and as one of the, like inside the function?
You can maybe do something like that.
Instead of making it a global variable.
Yeah. So that's a good idea. So the global variable thing works, but it's basically an invitation for bugs. So in this program, it'll be fine, but in this is really not reusable anymore. We can do is put it right here. And this also works. It seems a little strange, but what happens, has anyone ever heard of something called a closure? So this is slightly more advanced JavaScript. So no one's heard of a closure? It's a little surprising, but a closure, yeah. So what a closure is, basically, we have this function here. In this case, it's an inner function, and it's referencing some variable outside of itself here. So this inner function scope is just right here, right? So in normal JavaScript, this is all that exists. I call this function once, it returns this function, so that's it, right? It returns this function, so all this stuff should just disappear because it's not being used anymore. But there's a trick or whatever of JavaScript and other languages where, because this is being referenced in here, this is not going to get thrown away. This is going to get stored. So now this function actually can have reference. So I mean, we talked a little bit about private and public fields before. This is one way to create a truly private value in JavaScript. I cannot access this value directly from outside it. I can only call this function and modify this value. So I can only change this indirectly. I have no direct access to it. So we can use a closure to get this value, and that's kind of the trick for solving something like this. All right. So this is a lot. It's kind of brain breaking. So let's take a 5-minute break, and then we'll come back and we're gonna kind of do the same thing in Python. Python has a nice syntax feature that allows us to use these kinds of functions more easily. So come back in 5 minutes. Recording. Screen again. All right. So we've just seen implementing once in JavaScript. So it's a higher order function that both takes a function and returns a function and kind of tweaks the behavior, right? So in Python, we can do the exact same thing because in Python, functions are objects. We can do all that kinds of stuff. So let's just implement once in Python now. So def once, and what does once take in as a parameter?
Another function.
Yep. So it takes in a function and it returns a function. So the syntax is a little more awkward. In JavaScript, this is slightly easier. So we're gonna have to define the function and then return it afterwards, basically on a new line. So just syntax difference in Python. So def, I'm gonna call this inner function. You can choose whatever name you want. I don't really, it's basically anonymous. I don't care about it, what it's called here. We're just returning an anonymous function in JavaScript. So I'm just going to call it inner. And then, well, I guess we can use the same double function as a baseline. So it's good. So return func and then the number. So that means inner is going to have to take this number, and I'm going to return inner. So that should look familiar, the concept, right? So once takes a function and it returns this function. Here we have to return it on a separate line, but here's the function that it returns, and the function that it returns takes in some parameter and then calls the function that it accepts with the parameter and returns that value. So we're gonna have to do the same thing. So let's write another function, double. And then if we were to call this, we would call once with double, and then whatever the ultimate value we want is going to be doubled once, and we're going to pass in whatever number we want doubled, and then we can print that. So we should see 6, just like we saw with the JavaScript function. So let's get back to the guts of here. So we'll just run this. So we get 6. So this works. So the guts are correct. Now let's get the actual logic here. So what do we have to do?
Set a variable into true.
Okay. So we're gonna have some kind of variable. So we'll do I think we called it is callable. So if is callable, we'll do this. Otherwise, we'll just return nothing. Okay. And if we try to run this, we get let's try calling this again. I was expecting to have to use the non-local here. My version of Python is if this has changed. In either case, you may have to specify this as non-local here. Oh, well, okay, never mind. I know.
Do we need to change it to false?
Yeah, exactly. Yeah, thank you. So is callable false. There we go. It's the error I was expecting. So we get this kind of odd error, unbound local error. Local variable is callable, reference before assignment. So this is just a Python thing. So we just need, so it's, you know, it's got the same thing going on as here. There's a closure here, so it needs to capture this. Python will do that, but you need to mark this as being specifically referring to this. Otherwise, it's going to assume that this is just a variable inside here. And since you haven't defined it yet, it throws an error. So you just need to tell it explicitly non-local is callable. So you're basically saying, hey, this is callable that I'm using here in this function actually refers to this thing out here. And now that works. So the first call returns the value, the second call fails and returns none. We could also just maybe throw an error here or do something else. And functional programming, by the way, you don't throw errors. There's other ways of doing stuff. Okay, so that's the basic idea. Let's do one more quick example of the whole point of this. So this is just like JavaScript so far, right? So we have this function and we call once and assign it and then call it again, blah blah blah. So Python actually gives us a very nice syntax feature where we can decorate double, and we can decorate it with once. So there are built-in decorators. You could make your own in Python. We just made our own. Once, you just have to write a function that takes the function and returns a function. And now, anytime we call double, it's automatically going to like do what we did here. So we can just call double directly.
That's cheating.
I know. Too easy. So this behaves the exact same way, just minus this extra step. So we get this nice syntax. It also, you know, if you write a say instead of doubling this for like, you know, submit credit card payment or something like that, you mark that with once, and then you can reuse once elsewhere in your code base. It's a general utility that kind of modifies something else. So you're adding some functionality, you're changing how it's executed or doing something else. So that pattern can be useful. That's one way in functional programming of avoiding repetition and making modifications and customization.
So once is applied only to the preceding definition.
Yeah. So once is only, so I'm decorating double. So I could have another function called and I can call this one as many times as I want. And then if I also decorate this one, now I can only call it once.
Cool. And then sorry, just one more question. Is once, are you able to also put that before your call to the function, or does it have to be before the definition?
Yeah, it's just before. That's a good question. It's just before the definition.
Thanks.
So a decorator, this is, so this stuff is not like simple, but this is what's actually happened. The decorator is just, convenient syntax for describing this and then what we did here. All right, let's look at one simpler example. So you can basically do anything you want here. You get the function and the parameters, and then you can do whatever you want. So we're gonna write, a decorator that is, we'll call it Orwellian math, and anytime we pass in, let's say 2 + 2, it's going to return 5. So we'll call, I think I spelled that right, but maybe not. And like all of these functions, it's going to take a function with a parameter, and it's going to return a function. So I'm going to define that here. I'm going to call it inner because I don't care. And let's say, so we'll talk about making this more general, but for now, let's say I'm only going to use it for functions that add 2 numbers together. So I get 2 parameters, and then if A is 2 and B is 2, return func 2, 3. Or let's just say I'll do A and 3. And I'm going to return this function. So not calling it, just returning the function. So that's my, decorator here. So now I can just have a normal def add. Yeah. A, B, return A plus B. So if I call this here, so this works as you'd expect, just the normal function. And now what happens if I decorate this? Let's call it. And now I get 5. And if I call it with something else, it just behaves normally. So now I have, I have this general, let's say, this general purpose function or utility that I can use, and I can now modify this. This is a silly example, but just to show that you can alter the parameters as well. You can, I could log something and then call the function. You could do a side effect and then call the function. You can change the parameters. You could, you could do like type checking or making sure that something is a correct value, something like that.
Feels just like we're back in 1984.
Exactly. Yeah. So yeah, so I mean, it's a pattern that you can use, and there's lots of things you can do with it, but that's the basic pattern.
So just for clarification, I'm pretty sure I have it. I just want to make sure that I do. So when you decorate add with Orwellian math, you're basically just saying add is what I want to put inside of Orwellian math as its parameter, and then conduct Orwellian math on that. Okay.
Exactly. So it's like it's the equivalent of doing, Orwellian math add to something like that. So you could also do it this way, which is, you could do it in one line. I'll have to print this out, but so the way I showed you before was we call this, assign it to a variable, which is a function, and then we call it on the next line, but you can do it on the same line too. So in case you want to be even more confused, you can do that as well.
Why would 2 and 2 not be adjacent to add in those parentheses?
Yeah, so that's a good question. Can anyone answer that?
Is it because we're doing the Orwellian math on the add function, so it's taking in add as the parameter, not the 2 and 2 that should be done beforehand?
Yeah, so add, we need add to be a function. If we do this, if we do 2 and 2, then what is add going to be?
Oh, it has a return value, and then you're not putting in a function. Right?
Exactly. So if we try to call this, we get an error. Int is not callable. So add gets called, it returns a value, which is an integer, and then we're trying to call the integer as though it's a function.
Okay, that makes sense.
So then you also have to do you have to also make sure your inner function accepts the same number of arguments?
Yeah, so there are ways of making this general. So here we're saying you have to have exactly 2 parameters. You can do something like so here's this asterisk, which basically will allow you to accept any number of arguments. You don't care. So you can do something like that, and that way you could do, I think should be just yeah. So the way I have it set up here, I have to change my conditionals to check differently. I can't rely on this, but the general way you do that is args. There's args and quargs. You may have seen this. 2 asterisks for quargs. But that's how you could make, you can and should make your inner functions flexible like that. So yeah. So let me just try and do this. So args, I believe this is, I can do this. So let me use the decorator. So now I could, it wouldn't make sense. This is very specific utility here, but I could have some other function. And then I can call that print add more. Missing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, Orwellian math. Add more missing 4 required conditional arguments. I have to pass this in as a deconstruct the arguments there. So so this is how you do that. So the single asterisk, basically, I think it actually ends up being a tuple. So you can access it here through the normal like list or tuple access syntax. And then when I pass it on, I like deconstruct it again so it gets individual. It basically will take the list of args and then break it up into individual arguments that it passes in. So in this case, this doesn't really make sense, but that's how you can make it basically agnostic to the arguments. Okay, cool. Yeah, so why don't we take a 5-minute break?